Hi guys, this is Mr. Urrego, and today we're going to solve some trig functions. Okay, right now this is composition of functions using trigonometric functions. We have to find the tangent of my inverse cosine of 2/3. How do we start? The idea is we have different functions, and I have my inverse function on the inside. So every time I have the inverse function, what I'm looking for is an angle. So cosine -1 of 2/3, here my answer to all this is an angle. So let me call that angle theta. Okay, my answer to this is an angle theta. So that's how I'm going to start. I'm going to say that theta is cosine inverse of 2/3. Okay, because this is going to be an angle. Now, if my theta is the inverse of cosine, then I can say that cosine of this angle is equal to this ratio, 2/3, and that's what I want to get. Again, all this is equal to my angle. Angle is cosine inverse of 2/3. If my inverse of the cosine is my theta, then cosine of the angle equals 2/3, and this is my ratio. If you remember, the ratio for the cosine is adjacent over hypotenuse. So my ratio for cosine is adjacent over hypotenuse. I need to know this. Why? Because I'm going to go, if you notice, I have a triangle right here. I need to put those answers into a triangle. I have my ratio, so my adjacent side is going to be 2, and my hypotenuse is going to be 3. This is going to call, I'm going to call this my angle theta. Okay? My adjacent is going to be the base, and that's going to be my 2. And my hypotenuse is going to be 3, which is going to be the opposite side to my 90-degree angle. Okay, now I have something. Then what? My final answer, they're asking me tangent of this angle, tangent of this function. To find the tangent of my angle, remember my ratio. Tangent is opposite over adjacent. So I'm going to go to my triangle and says, all right, hold on, this is my angle. Opposite is this. Do I know my opposite? No, I don't. So let's just call that y. So I don't have that. All right, do I have my adjacent? Yes, which is 2. So that means I have to find the value of y to get my final answer for this composition of functions. Now I have a right triangle. I have 2 sides and I don't have the third side. Right triangle, yes, I'm going to use my Pythagorean theorem. A squared plus b squared equals c squared. Again, this is one of the most useful theorems in trigonometry. And in right triangles, obviously. Okay, A could be any of the two. Remember, A and B are the legs of the triangle. C is your hypotenuse, so this is C. There's no question about that, so that's C. The other 2 sides doesn't matter, so I'm going to call this 2, I'm going to call that my A. And my B, in this case, I'm going to call the other side on my other leg, which is B. Which is Y. So I have 2 squared plus y squared equals c squared, which is my 3 squared. Let's solve this. 2 squared is 4. Y squared. 3 squared is 9. Leave the y by itself, minus 4 on both sides. And I have y squared equals to 5. But remember, I don't want y squared, I want y. Square root on both sides, and this is going to cancel the y. Now, a little thing, here you should have plus or minus, okay? Remember, every time you do a square root on both sides of an equation, technically you have a plus and a minus square root of 5. But right now I'm talking about the side lengths of a triangle, so it doesn't make sense to have a negative side, so therefore I'm going to use only the positive side. Again, technically plus or minus because you're doing an equation and you're doing square roots on both sides, but because this is the length of a triangle, there's no negative lengths. Therefore, I use the square root of 5. So now my value of y is square root of 5. Let's bring it over here. Okay, now I have the 3 sides. Let me go back to my answer. Tangent of my theta, but again, I gotta go back to the original. Tangent of my inverse cosine of 2/3 equals Tangent is opposite over adjacent. This is my angle. Opposite is square root of 5. Adjacent 2. And we're done. So all these type of composition functions, this is the way we solve it. We get our theta, my inside function, I call it theta. I call that theta go to cosine of the angle. I create my triangle. I make sure that I have all the sides. Most likely I have to use my Pythagorean theorem. And once I have that, I go back to my original function and replace the two sides that I'm looking for. All right, let's do one more. Okay, so let's solve another one. We have cosine of arc sine of -3/5. You notice that instead of putting sine of -1, I put arc sine. This is the same as the inverse function, okay? So this is the same as inverse function. This is the same as having, let me get a pen. Having this is the same as having sine -1, all right? Different notation, okay? Arc sine is the same as sine -1. Same thing as the previous one. My function is my inverse function. My answer of this is going to be an angle. Okay, where's my angle? Where my sine is -3/5. Okay, what's my angle? Where my sine is -3/5. So I'm going to grab to this. Okay, and let's work it on the side. So theta equals my arc sine. I'm going to stay with that notation, so we learn this notation as well. Arc sine of -3/5. Okay, therefore my sine of theta is equal to my ratio -3/5. Okay, but where's my sine negative? Remember, my sine is negative in Q3 and Q4. All right, so sine negative, but my inverse function is only defined in Q1 and Q4 from -pi/2 to pi/2. My sine inverse is defined between -pi/2 all the way to pi/2. So let me create this triangle. I have theta is -3/5. My sine is negative here in Q4. Here my sine is negative. Okay, because remember, sine is your y and your y is negative here. Alright, so let's create a triangle. Let's get a blue color here to make a difference. And let's make my, here we go, something like that. This is going to be my angle theta. Okay, alright. And technically, remember, -3/5 is opposite over hypotenuse. As a distance, this is a positive distance, but in direction, this is -3. Okay, my sine is negative here. My hypotenuse is always positive. Okay, so as a distance, not as a distance, as a direction, this is negative because I'm going down. All right, that's the reason. Okay, my sine is -3/5. Same thing as before. Now, what I'm looking for is I'm looking for my cosine. And remember, my cosine of the angle is adjacent over hypotenuse. My adjacent to the angle is this. Let's call that x. This side is my adjacent. Therefore, I gotta use the Pythagorean theorem again. So let's do that. So it's going to be a squared plus b squared equals c squared. Remember, this is your hypotenuse. The c value is the hypotenuse, which is your 5. So I'm going to replace here 5 squared. A, it doesn't matter which one it is. I only call it ax. And then the b is going to be -3 to the second power. It doesn't matter put the negative there or not because it's going to be raised to the second power. So I'm going to have 3 -3 squared is going to give me 9. Equals 5 squared, which is 25. Then -9, and I'll have x squared equals 16. I need square root, and remember, I'm going to have a plus or minus 4, but I'm looking for a distance, so my answer is +4. Now, x is 4. This is a famous Pythagorean triple. 3, 4, 5. 3, 4. If your two legs are 3 and 4, then your hypotenuse is always 5. Alright, keep that in mind. Once I have that, plug it back in. Alright, now I have my adjacent side. Let's go to my final answer. My final answer is cosine of my inverse function, my arc sine of -3/5. Remember, my cosine is positive in Q1 and Q4, so this is going to be positive anyway. So my cosine of this thing is adjacent over hypotenuse. My adjacent is 4, my hypotenuse is 5. Okay, and I'm done with that problem. All right, let's do one more with variables. Let's do one more variables. Okay, now we have another problem, same idea, but now we have variables. So they're saying if x is between 0 and 1 and being equal to 1, write the cosine of the inverse of sine of x as an algebraic expression in x. Couple things. X is between 0 and 1. Alright? Greater than 0, less than or equal to 1. Why? Because my cosine function is defined between 0 and 1. Sine inverse. Remember here, my inverse function, that's going to be an angle theta. Okay? And that angle is between -π/2 to π/2, but right now everything is in terms of x. The idea is the same. Whatever is here, my inverse function, I'm going to call that theta. So I have sine -1 of x. Alright? If my theta is the inverse sine of that, therefore my sine of theta is x. This ratio. Right now it's not a ratio, but let's make it a ratio. Okay, so here we go. Now what? Now this is to help me make the triangle. So my sine is opposite over hypotenuse. So that means this is opposite and this is hypotenuse. I got my triangle. This is my angle theta. Opposite is x. Hypotenuse is 1. Alright, I'm ready. What is my answer? I'm looking for cosine. If you remember, cosine of the angle is adjacent over hypotenuse. I'm going to go to my triangle. Do I have adjacent? Oh, I should have done, okay. We use the x. So adjacent is right next to the angle. So let's call this M. Alright, this is the adjacent side. Adjacent to my angle. That means I got to find the value of M. Again, Pythagorean theorem. A squared plus b squared equals c squared. A, I'm going to call that M. My b is the other leg, which is x squared, and my hypotenuse is always the c value. That means m squared plus x squared equals 1, and I'm solving for m, meaning minus x squared, and then I have m squared equals 1 minus x squared, but I need m, I don't need x squared. Therefore, square root, my m is equal to square root of 1 minus x squared. Alright, and now I have my adjacent side. Now it's a matter of just plugging back into my function. Remember, they say write this as an algebraic expression in x, in terms of x. Let's go. Cosine of my sine inverse of x equals, what's my cosine? Adjacent over hypotenuse. Adjacent is m. What's m? Square root of 1 minus x squared divided by hypotenuse. What's my hypotenuse? 1. Final answer. Cosine of my sine inverse of x equals this divided by 1, which is 1 minus x squared. Again, I didn't solve for anything. I'm leaving everything in terms of x. As you can see, it's the same process. So don't just get confused or aggravated or stressed out because you have a variable. Use the same process. When you have an inverse, sine of -1, when you have an inverse function inside the parentheses, your answer is an angle. Therefore, transform it as an angle and then work it out. If you have a sine of inverse, then you make your sine of the angle, and so on and so forth. Guys, I hope this helps. I hope you're understanding. If this helped you a little bit, please like the video, subscribe to the channel, and thank you for watching, as always.